Namaskar, good afternoon. You are watching Kishore Manch SWAYAM Prabha channel number 31 and NCERT's official YouTube channel. I am Rahul and we bring you the session of mathematics class 11th and the topic is trigonometric functions, and today we are going to learn part 4. We have already seen part 1, 2 and 3. So trigonometry is very interesting if you understand the trigonometric functions, theorems and some conditions which are mandatory to solve the equations. And today we are going to learn from Dr. Ajit Thomas. We'll connect with him in a while. You just note down our toll free numbers 1800-111-265 and another number is 1800-112-199. And if you would like to send us an email, that would be really great on ciet.kishoremanch@gmail.com. So these are the easiest way to connect with us. CIET, NCERT is trying our best to provide all the digital lessons, subjects with almost every teacher. We are trying to get them here with this digital channel. So we try hard, but these जो भी हमारे कहना चाहिए कि एफर्ट्स हैं वो पूरे तभी होंगे जब आप समझ लेंगे और अपनी प्रैक्टिस घर पे जारी रखेंगे, बिकॉज योर प्रैक्टिस विल गिव अस द रिजल्ट्स. सो प्लीज वेलकम डॉक्टर अजीत थॉमस. लेट्स कनेक्ट. हाय डॉक्टर थॉमस. नमस्कार. हाउ आर यू सर?
Namaskar. Fine, I am fine.
Good to see you sir. Good to connect again. So let's start. Yes. Trigonometric functions part 4. Okay.
So actually this is trigonometry function part 4. Already we had 3 sessions on this.
Okay.
So students, we started with trigonometric functions. We defined what are the units of how you measure angles. So there are 2 measurements of angles, degree and radians. So we learned how to convert degree to radians and radians to degree. Then we started with functions, trigonometric functions. We defined first sin x, sine function and cos function in terms of by taking a unit circle. Then we define other trigonometric functions like tan, cot, cosec and sec. So what is left now is to plot the graph. As we have discussed in the last session that these are trigonometric functions and these are real valued function, and there exists a graph for the real valued function. So in this session we will try to plot all the graph for these trigonometric functions. So let us start with a very fast revision of what we have done. So this is how we define sine and cosine function.
Okay.
So you can see that this is a unit circle. If I take any point on this unit circle, it will be represented as a comma b. If I am saying that this is the coordinate a comma b, the first component is a, the second component is b, then with respect to this angle, you can see that the point is also going to change. So if you have an angle x, then corresponding to this angle, this a is defined and this b is defined. And it is also that there is only one a for x, there will be one a. So there is a 1-1 correspondence between this x and a, or you talk x and b. So what is this a? We define the trigonometric function, the first trigonometric function, that is cos function, as this a. So cos of x is a and sine of x is b. So you can see in the figure that there is a representation for this a and b. So if you see that this a is represented by this blue line and this b is represented by this orange line. So how you will get? You just drop a perpendicular from this point P on the x-axis. The distance from x-axis, wherever that line will meet the x-axis, that distance would be a, and that would be cos of x. And the perpendicular distance, perpendicular length that is drawn from P to the x-axis is sine x. So this is how we define. Fundamentally we define sine x and cos x. And further we have defined other trigonometric functions. So we have seen that in the last session only, we have seen that sine x and cos x, they are 0. So since we are defining other trigonometric function in terms of sine x and cos x, so we have to see that where it is defined and where it is not defined. For example, if you see cosec x is defined as reciprocal of sine x. So this means that wherever sine x is 0, this cosec x will not be defined. And we have learned that sine x is 0 when it is n pi. So cosec x is defined as reciprocal of sine x, but since sine x is not defined, is 0 at all the integral multiple of pi, 2 pi, 3 pi, 4 pi, and negative also. We have seen that there can be negative angle. If you take in clockwise direction, then the angle is taken as negative. So for all the integral multiple of pi, this cosec x is cosec x is not defined, because in that case it would be divided by 0. So similarly, you can see sec x is defined as reciprocal of cosec x, and you can make out now that where the sec x is not defined, at the point where cos x is 0, and you can see that cos x is 0 at the odd multiple of pi by 2. Similarly, tan x is defined in terms of sin x and cos x, and cot x is defined in terms of cos x and sin x. As I told you that so these are real valued function, and for real valued function we have graph, and how the graph is drawn, this we have discussed in the last session, but we are going to revise that also. Before that, we have seen what is the domain and range of sine and cosine function. So sine and cosine function, the value of sine and cosine function lies between -1 and +1. And you know why does it lies between -1 and +1? Because this we have discussed in the last session. And range, that is actually the range. And what is the domain? Domain is since it is defined for each and every real number, so domain is the entire real number, and the range, the value for which sine and cosine lies, between which sine and cosine lies, is -1 and +1. So first of all, we are going to see how to draw the graph, or how to plot the graph of sine x and cosine x. Then we will come to other trigonometry. So this is all we have done in the last session. So before that, we should have an understanding of what is a graph of a real valued function. To get an understanding of a graph, I'm going to do just a fast revision of what we have done. For example, you can see on the screen that this is a function. This is a function whose domain is real number, and whose codomain is also real number. Okay. So you can see that this function is x plus 1. This means that for every point there is an associated number to that point. For example, if I take x equals to 1, you will see that for 1 it is, the value of function is 2, because when I substitute x equals to 1 over here, I will get 1 plus 1. So corresponding to this, what I got a point like this, 1, 2. So what is graph then? The graph is collection of such points. So if you have a function, if you have a real valued function, you get coordinate points like this. You got coordinate points like this. In this case, there are infinite number of coordinate points. When you collect all these points, you are going to get a graph for this function. Now, what is 1, if I want to plot this 1, 2, what does it mean? So you can see that there is a Cartesian plane I have used over here. So 1, 2, what does this 1 means? 1 means this distance. What does 1 means? 1 means this distance. You can see on the screen, this distance is 1. And what is this 2? 2 means this height. 2 means near. So if I'm going to, if I want to plot this point, then I have to put this point over here. See, 1, 2. So it has a point, reference. So this is a reference point with respect to this Cartesian plane. It has x, it is 1 unit from the y-axis and 2 unit from the x-axis. Okay, so you can see that you will get other points like 2, 3. Okay, so if you want to plot 2, 3, I can plot over here. And since you know that similarly for 3, 4, 3, for 3 I will get 3, 4, for 4 I will get 5. So you got all these points. There are infinite number of points that we are going to get. So when you are going to collect this, when you are going to collect this, what you are going to get? You are going to get a graph. So this is what I mean by a graph. So this is what I want to do for sine and cosine function. I want to draw a graph for sine and cosine function. So you should understand that what is the domain and what is codomain and what is range. So we have discussed that. So we are going to come to that only now.
Okay.
So uh, to see what is the graph of sine and cosine function, let us go to the software, that is GeoGebra software. Okay, so now you are well aware of this software. So what I have done over here, you can see that this is a unit circle. You can see that this is a unit circle. In this unit circle, this is how I define sine alpha. For this alpha, alpha means the angle. So in this case, what is the angle now? Angle is BA. So you can see that there is a point A which is the center. So BAP. So at the present moment, the angle alpha is BAP. So for this particular alpha, what is sine alpha? Sine alpha means this height, because as I told you, the coordinate, you can see the coordinate of P, it is 0.36, 0.93. So this means that your alpha is this is for the alpha is 0.36 and the point is 0.93. So this means that to plot, I have to plot these coordinate points. I have to plot, actually I have to see for this alpha, this height, actually this height is given by this 0.93, and on x-axis, this is your x-axis, I have taken the angles. So for alpha equals, you can see that there is a slider over here. This alpha is 1.2. So this means that for this 1.2, the coordinate that I have to take is 0.93. So this is 1 point. Similarly, what you are going to get infinite number of points. So let us see how it will be drawn. So let us have an idea that, see, as I'm increasing the angle, what is happening to sine? Sine is increasing to a particular level, that is 1, because this is a unit circle. So let us start from the very beginning. Let us start from 0. Okay, so this is angle is 0. So when angle is 0, what is sine? Just see what is sine. When this angle is 0, the sine has completely collapsed. The height has completely collapsed. So this means that sine at this particular moment is 0. So the point corresponding to 0 is 0. So you got the coordinate as 0, 0. So let us plot this point. So you can see that I have plotted the point. You got it. So you can see that this blue dot, this is actually the point of the graph corresponding to this alpha. So when alpha equals to 0, so you can see that on x-axis I'm taking alpha, on x-axis I'm taking it at 0 level. So x at 0, what is the value of y? So on y-axis I'm taking the value of sine at this particular moment. So what is y? So 0, 0. So this is the point. So let me move a little further. Just have a look what is happening. So as I move further, just see what is happening. Your sine is increasing. Your sine is increasing, the height is increasing, and corresponding. So the 0.3 means that on this x-axis I have to take 0.3. So this point would be 0.3. So this means that this height is 0.3 and it is also 0.3. And here also you can see that this sine alpha is increasing. So as I'm going to increase it, you just see this height and this height would be same. Just see how my mouse is moving. So this height and this height, this sine alpha, this one, and this alpha means the point of reference. So you can see that this alpha is 0.5, and you can see the slider also, it is 0.5. So I'm going to increase it further. So just see how both things are moving. Just have a look at how this line which is in blue line, and this point, how it is moving. So it is moving. Now you can make a guess that it will move up till 1. So because this is a unit circle and the maximum height, because the height is increasing, the sine alpha is increasing, it can reach up till this point. And what is this point?
ओके, सो ये इसका मतलब है कि जैसे ही उस यूनिट सर्कल में वो पॉइंट मूव करता रहेगा तो आपके कोऑर्डिनेट्स जो है चेंज होते रहेंगे और अल्फा की जो वैल्यू है वो भी चेंज होती रहेगी। अभी कुछ तकनीकी कारणों की वजह से शायद हमारा संपर्क डॉक्टर अजी थॉमस से टूट गया है। एक बार फिर से हम ट्राई करते हैं। इफ़ ही इज़ गेटिंग आवर वॉइस। डॉक्टर थॉमस, कैन यू हियर अस? शायद उन तक हमारी आवाज़ नहीं पहुंच रही है और हमें भी उनकी आवाज़ नहीं मिल रही है। तो ये जो साइन और कोसाइन का उन्होंने जो एक रिलेशन बताया, इसको जानने के लिए ये उन्होंने आपको जितने भी थ्योरम्स और जो पॉइंटर्स बताए हैं वो आपको याद होना बहुत ज़रूरी है, और जो वो ये समझा रहे हैं सॉफ्टवेयर के थ्रू कि कैसे आप उस यूनिट सर्कल में अपना जो एंगल है उसको डिफाइन करेंगे, ये सारी चीज़ें बहुत बारीकी से, ट्रिग्नोमेट्री का एक फॉर्म है और ट्रिग्नोमेट्रिक फंक्शंस की आज हम बात कर रहे हैं. दिस इज़ द पार्ट 4. सो वी हैव ऑलरेडी वॉच्ड पार्ट 1, 2, 3. आप जब ये सेशन ख़त्म होगा तो आपके पास YouTube पर जो NCERT का ऑफिशियल YouTube पेज है उस पर ये सारे सेशंस अपलोडेड हैं. आप इन्हें एक साथ रिवाइज करने के लिए देखिएगा तो आपको पूरा एक सीक्वेंस में याद हो जाएगा कि व्हाट आर द ट्रिग्नोमेट्रिक फंक्शंस. इस वजह से आपके पास ये एक चॉइस रहेगी कि आप प्रैक्टिस जब करेंगे तो जिस सेशन में भी आपके काम का जो भी कुछ है उसको आप रिवाइज कर सकते हैं, देख सकते हैं, सुन सकते हैं, समझ सकते हैं, एंड देन यू कैन प्रोसीड. क्योंकि जैसे ही आप ये करेंगे उसके बाद ही आप ये मानकर चलिए कि आप अपने जो भी एग्ज़ाम में क्वेश्चंस आने वाले हैं, क्योंकि वो सारे क्वेश्चंस सेम नहीं होते हैं लेकिन उनको सॉल्व करने का तरीका सेम होता है. ये देखिए आप स्क्रीन पर इस वक्त जो सॉफ्टवेयर दिखाई दे रहा है यूनिट सर्कल उसमें बना हुआ है, और अभी फ़िलहाल एक्स एक्सेस पर कुछ भी नहीं है, वाई एक्सेस पर वो ले गए हैं. तो मुझे लगता है कि वो आपको एक प्रैक्टिकल करके दिखा रहे हैं जिसकी वजह से आप ये समझ पाएंगे कि जो एंगल डिफाइन करना है, जो अल्फ़ा की वैल्यू है वो कैसे चेंज हो रही है एज पर द पॉइंटर. सो डॉक्टर थॉमस, कैन यू हियर अस?
Yes, yes, yes.
ओके, थैंक यू. मुझे लग रहा है शायद कुछ ड्यू टू टेक्निकल फॉल्ट
There was some technical problem.
ओके, नो
Okay.
इश्यूज.
Okay.
नाउ so now is it stable?
Yeah, yeah.
Okay, please
So
continue.
student, what we were discussing? We were discussing that in this alpha means the angle. So corresponding to this alpha, as I'm increasing the alpha, so we were here, as we're increasing our alpha, this sine alpha is increasing, and it can increase to a certain level. What level is that? That is 1. So you can see that at pi by 2, the maximum height that sine function can reach is 1. But as I move further, you can see that this height is decreasing now. So this height is decreasing. So as I'm going to move further, you can see that this height is decreasing, which is this height. So you can see the pointer, just see the pointer. So this height and this height is one and the same. And this corresponds to this. If I put the pointer over here, you can see that this is 2.1 comma 0.86. So what does this mean? This means that the point on the x-axis it's 2.1 and the height is 0.86. So this height is also 0.86. So you can see that this height is 0.86, and if I put the point over here, you can see that it is also 0.86. So as I move further, just see what is happening. This is what is happening. It reached pi. Pi means 180 degree. You can see that. And you know that we have discussed that when is sine 0, sine becomes 0 at 180 degree or pi radian. So you can see that it has become 0. Now see, if we move further means greater than 180 degree, this height is increasing but in negative direction. So you can see that that's why the point is in the negative y-axis. So you can see that the point is 3.6. means that 3.6 comma minus 0.44. So corresponding to 0.66, what is this height? This height is minus 0. And why this minus? Because this is in the negative y direction. So if you take any point in the third quadrant, you know that in that case y is negative. So let me increase it, and you can see that it will become minus 1, and after becoming minus 1, it will now increase in the sense that this height is going to decrease. Negative is so what is happening? The height is decreasing, but it is as a numerical form it is increasing.
Yes.
So it is increasing up till when it becomes 0 at 2 pi. So this is how the sine is plotted. Now this will go till infinity. So that's why this sine function is defined for every real number. So I can increase the angle, because when I'm going to take one more turn, it means that that angle is greater than 360 degree. Okay, so if we take one more turn, then the angle is going to increase, and it is going to continue now. Now let us have a look at what will happen when we move in anti-clockwise direction. So when we are moving in the anti-clockwise direction, you just see that what is this? What is this length? Length in the negative direction. So this means that it is decreasing because it is negative. That's why I'm saying decreasing. So it will decrease up to which level? It will decrease up to this level. And what will be the value of y at this level? The value of y would be -1. So this is how. So you can see that the angle. So you can see here that the angle has become negative. So for corresponding to negative, this height is 0.86 at this particular moment. So it will go and it will see now it has become negative 180 degree. Now the height is increasing. Now the height is increasing. So this is how the sine graph looks like. And you can see that if I plot this graph, you can see that now I plotted the graph. You can see that this is how it looks like. It is you can see that from 0 to pi, 2 pi, 0 to 2 pi, if you have a notice at this portion, 0 to 2 pi portion, this portion is repeating after 2 pi to 4 pi. 2 pi to 4 pi, this portion is repeating. 0 to 2 pi, the same graph you can see one loop upward and one loop downward. The same thing over here, one loop upward and one loop downward. So such type of function is known as periodic function, and it has a wide application in other branches of science where we study wave theory and other concepts. So you can see that this is how the sine looks like. Now let us see how draw the graph of cos. Let us draw the graph of cos. Now how cos will look? So let us analyze this now.
Okay.
What is cos? So you can see that, let me bring to this 0. First I'm going to start with 0. So you can see that at the starting, very starting, when alpha is 0, at angle alpha is 0, what is cos alpha? Cos alpha is this orange line. And what is this? This is actually the radius of the circle. What is the radius of the circle? The radius of the circle is 1. So what does it mean? This means that corresponding to 0, the value of cos alpha is 1. So what will be the first point corresponding to 0? It will be 0, 1. So let me plot that point now. So this is the point. So you can see that this point, which is shown in this red dot, this is actually the point on the graph of cos x corresponding to 0. So on 0, what is the height? So this height and this length would be the same. Okay, so this is 0. So and this so if I move further, let me see. If I move further, what is happening to cos? What is happening to this cos? It is decreasing. So this means that this height is also decreasing. And what is this height? This is exactly equals to this line, this orange line. This height and this orange line is one and the same thing. If I put a point over there, so you can see that it is 0.4, 0.92. This means that corresponding to alpha equals to 0.4, the value of cos is 0.92. So this 0.92 means this height and as well as this cos alpha, this is how this cos alpha is defined. So this height, you can see the movement of the cursor, this height and this cos alpha, this is one and the same thing. So if I'm going to increase it, you can see that we are going to trace the cos curve. So you can see that the cos is decreasing, a particular angle that is 90 degree, it becomes 0. And you know that when is cos 0? So odd multiples of pi by 2 or odd multiple of 90 degree, cos is 0. So it is becoming 0 over here. So if I'm going to increase the angle, you can see that you can see that cos is moving. At this particular moment, it becomes the height becomes -1 because it is pointing towards. Now this should be clear that it is pointing towards the point is in the negative y direction.
Yes.
So this distance is -1. That's why you can see that this point is now in this region, the fourth quadrant. Okay. So as I am going to increase, so you can see that what is happening to this cos now. This length is decreasing, but it's in the negative, so it is increasing. So it is increasing So it will increase up till 0. So minus 1 to 0. So in this third quadrant, it increased from minus 0. And now see, so we have studied that about the trigonometric function, where it is positive and where it is negative. So you can see over here in the fourth quadrant means 3 pi by 2 to 2 pi. In this, as it entered this quadrant, the point become positive, means cos become positive. So in the fourth quadrant, cos is positive. That we have learned in the last session. So you can see that it is increased. So this is how cos in the first, second, third, and the fourth quadrant. Now I can go in the clockwise direction also. In that case, angle would be negative. So you just have a look at this cursor. The point, this, you will see that slider. You will see that this alpha is becoming. So as I move in clockwise direction, it becomes negative. So see, I'm moving in the clockwise direction, it becomes negative. Again, the point will plot the entire, this height and this cos alpha will be one, in this height and this cos alpha, this cos alpha. This is how this cos alpha is defined. This will decrease, finally it will reach minus, it will reach, and in that case the cos, you can see that cos has completely collapsed, it becomes 0, and now see it is increasing but in negative direction. That's why I'm saying decreasing, further it decrease up till minus 1 it decreased. Now see, it is increasing. Okay, so this is how the cos graph is plotted. Okay, again, if you see the graph for this cos, let me draw the graph. You can see that it is again, see this loop and this loop is one and the same thing. Again this loop, it is repeating over again and again. So that's why cos is also a periodic function. Okay. After 2 pi it is repeating. After, if you add an angle and 2 pi, you will get the same value of cos. So this is how the sine and cosine function, how to plot sine and cosine function. So let us come back to our slide and see. We have seen what is sine and cosine now. Now we can talk about the nature of sine and cosine function. We can talk about the nature of sine and cosine function. So you can see that I have drawn, for your convenience, I have drawn the graph over here. The same graph which we have plotted in the GeoGebra software, I have drawn for the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so you can see that this is sine and cosine. So first quadrant, so this is for the first, this is for the second quadrant, this is the third quadrant, this is the fourth quadrant. First quadrant means angle ranging from 0 to 90, if I am talking in degree. And second quadrant means angle ranging from 90 to 180. Third quadrant means angle ranging from 180 to 270. And fourth quadrant means angle ranging from 270 to 360 degree. So for this, let us see what is the nature of the function. So you can see that what about this sine? Sine, you can see the graph which is drawn in orange color. You can see that this is 0, this is pi by 2. So what is happening to sine from 0 to pi by 2? What is this happening? The height is increasing, but that is also in positive direction. So this means that it increases. At this particular point it's 0 and it increases up to 1. So in the first quadrant, sine value ranges from 0 to 1. If we move to the second quadrant, that is pi by 2 to pi in radian. Pi by 2 means 90 degree in degree. So pi by 2 to pi, you can see that the graph is decreasing. Okay, so this means that it decreases from 1 to 0. So sine increases from 0 to 1 in the first quadrant and sine decreases from 1 to 0 in the second quadrant. In the third quadrant, you can see that what is happening. So this is your first quadrant, 0 to pi by 2. This is the second quadrant. Now you just have a look at the third quadrant. It is pi to 3 pi by 2. Pi to 3 pi by 2. So what is happening to pi to 3 pi by 2? This is decreasing. This is decreasing from 0 because the value of sine at this particular is 0 and it has gone till minus 1. So 0 to minus 1 means it is decreasing. It is decreasing till 0 to minus 1. And after that, from 3 pi by 2 to 2 pi means the fourth quadrant, you can see that at the fourth quadrant, it increases from -1 to pi. So this is the nature of this sine function. Similarly, you can see the nature of cos function. So if we, for this cos, if you see the first quadrant, first quadrant is from 0 to pi by 2. So you can see that from 0 to pi by 2, it decreases from 1 to 0. So you can see that it decreases from 1 to 0 from 1 to 0, decreases in the first quadrant. Similarly, you can see that in the second quadrant, what is value of cos at the very starting of the second quadrant? It is 0 and it becomes -1. So you can see that it becomes -1. So it decreases from 0 to -1. After that, you can see that -1 to 0, -1 to 0. So here the value of cos is -1 and it has gone till this 0. Similarly, you can see that in the fourth quadrant, it increases from 0 to -1 and so on. So you have seen that these are periodic functions. These are periodic functions because after a particular period, the graph repeats itself. Now, we are going to see other nature like nature of cosec x. So to find the cosec of nature of cosec x, let us go to the software again and see what is cosec x. So what is cosec x? How we have defined cosec x? Cosec x we have defined as the reciprocal of sine x. Cosec x is defined as the reciprocal of sine x. So cosec x, so this, and one thing that we have seen the definition of cosec x, that it is not defined at values where sine x is 0. So you have seen that what point sine x is 0. So sine x we have seen that then at pi. So this means that this cosec x will not be defined on at these points. Means integral multiple of pi. It will not be defined. Integral multiple of pi, it will not be. So let us see how cosec x looks. So let me bring the cursor to 0 now. Let us starting from 0. Let me bring the cursor to 0. So you can see that it is 0. Let me bring to 0. Okay. So it is 0 now. Now I am going to plot the point. So at alpha equals to 0, what is sine? Because it is defined in terms of sine. It is reciprocal of sine. So alpha equals to 0, what is sine? Sine is 0. So this means that at alpha equals to 0, this cosec will not be defined. So let me increase it further and let me plot the point. Okay, so this is the point. P cosec x. This red point you can see, this is cosec x. So what is happening to sine? When I'm increasing the alpha, what is happening to sine? What is happening to sine? Sine is increasing. So if sine is increasing, since cosec is reciprocal of sine, what does it mean? This means that cosec will decrease. So that's why you can see that the point is moving downward. This height is decreasing. This height is decreasing because sine is increasing. So if sine increases, cosec decreases because it is reciprocal of each other. So you can see that now sine, you can see that this is actually the sine. This is actually sine. So sine is increasing, but it can increase to a certain level up till 1. So this means that cosec can decrease up till 1. So cosec can decrease up till 1. So this height, is 1 now. So if I increase now, if I increase further, angle further, you will see that this sine is decreasing now. Sine means this blue line. This blue line is decreasing. So this blue line is decreasing. This means that cosec will increase. This cosec will increase. If you have a point, look at the point. It is increasing. It will increase.
Yes.
And when sine becomes 0, again, when sine becomes 0, cosec is not defined. So what is this line? This means that at pi, cosec will not be defined. So it will not be defined at this pi. Understood this? So this from 0 to pi, this is how cosec looks like. So if I move further, you will see that now the sine is, what is happening to sine? Sine is decreasing because it is in negative. That's why I'm saying decreasing. It is in negative.
Yes.
So you can see, but it can decrease to up to a certain level. What is that level? It can decrease up till -1. So it will decrease up till minus 1. It will decrease up till minus 1, and finally what is going to happen? The sine is going to increase. So if sine is going to increase, what is going to happen to cosec? Cosec is going to decrease. Okay, so this is how. So actually this is this would be in the form, it would be like this in the first 0 to pi, then from pi to 2 pi it would be like this, and now it is going to, if I am going to increase, it is going to repeat now. By the same analysis, you can see that it is going to repeat. So I will just draw how does the cosec looks like. So you can see that cosecs look like this. Again, it is an infinite graph. You can see that it goes till infinite. But here you can see that at pi it is not defined, at 2 pi it is not defined, at 3 pi it is not defined, 4 pi it is not defined, 5 pi it is not defined, 6 pi it is not defined, and so on. So, and negative also you can see that it is not defined for minus pi, it is not defined for minus 2 pi, and so on. So this means that, again it is a periodic function. It is a periodic function. It is defined. It is not defined for each and every real number. There are certain numbers for which it is not defined. So this is how the graph of sine looks like. So this is how graph of sine looks like. Now just by looking the graph, you can see what is the nature of this cosec x. You can see the nature of cosec x. So cosec x, it decreases from infinity to 1. Infinity means because as I am moving, as you can get close to 0, this line is going to go to, it increases indefinitely. Arbitrarily it increases. So that's why I'm using this symbol infinity to 1. So you can see that the sine, the cosec decreases from infinity to 1. Decreases from infinity to 1 in the first quadrant. First quadrant means 0 to pi by 2. From pi by 2 to pi, it increases. That's why it increases, but it increases from 1 to infinity. It increases from 1 to infinity. Again, you can see that from pi to 3 pi by 2, it increases from minus, now in the negative direction of y, it increases from minus infinity to minus 1. Again, in the fourth quadrant, it decreases from minus 1 to infinity. From here, we can claim what is the domain and what is the range. We have discussed what is domain and what is range for this function. So domain means the function at which it is defined. So what we have seen, the function is defined for every real number except integral multiple of pi. So how we are going to write the domain of cosec x now? So cosec x, domain for cosec x is x such that x is not equals to n pi, where x belongs to real number, and n belongs to integers. So all the real number except n pi, integral multiple of n pi would be the domain. So you can see in the graph also that it is not defined at pi, it is not defined at 2 pi, and so on. And what is range for this function? So you can see that the range varies from, if I see this particular point, what is the value of cos at this moment? It is 1. So it is not becoming less than 1. If we see this loop, it is not becoming less than 1. So so it goes from 1 to, and arbitrarily it grows. So all real number which is greater than 1, and if you see this loop, you see that it goes from minus, so this is minus 1, so minus 1 to all real number which is less than minus 1. So what is range now? What is range for this cosec x? So range for cosec x is all those y belonging to real number such that y is greater than equals to 1 or y is less than equals to minus 1. So this is how we define the domain and range of this function, cosec function. And I'm sure that you understood this, how to draw the graph. So of cosec x. Now likewise we can draw the graph of tan, cot, sec, all the remaining trigonometric function we can plot on the graph, and we can see. for just since we don't have much time, I suppose.
Yes,
I'm
yes.
just going
We have hardly
plot.
5 minutes, as you have already explained sine and cosec. I
Okay.
think, but the
So I will
rest
just
of the
come- I
functions
will-
will take time.
No, I will just, if I can do with tan. One more function I'm going to define. Then
Okay.
Okay. So how we are going to define tan now?
Okay.
So let us define tan.
So let's utilize this 5 minutes. So you will see.
Okay, I will just draw the graph of this tan.
Okay.
I will just draw the graph. I will not, because you can use the same analysis you can use to draw the graph of tan, cot, and so on. I'm not going through the analysis part, but I'm just drawing the part.
Okay.
Now just see, this is how tan looks like. This is how tan looks like. So you can see that again, the tan is defined for every real number. The tan is defined for every real number,
Okay.
but it is not defined for certain real number. Like pi by 2, it is not defined. Tan pi by 2. If you just see that at pi by 2, what is the value of sine? What is value of cos? Cos is 0, and tan is defined as ratio of sine and cos. Sine over cos is defined as tan. So this means
Okay.
that it is not defined at all the odd multiple of pi by 2. So you can
Okay.
see that it is not defined at pi by 2. It is not defined at 3 pi by 2. It is not defined at 5 pi by 2. It is not defined at 7 pi by 2. Similarly for the negative. So this is how the tan function looks like. So if
Okay.
you want to see cot, this is how cot looks like. Now cot, what is cot? Cot is reciprocal, is the ratio of cos over sine. Yes. So cos over sine. So this means that wherever sine is 0, it will not be defined. So where is sine 0? Sine is 0 is at 0. Sine is 0 at pi. Sine is 0 at 2 pi. So sine is 0 at all the integral multiple of pi. So this means that this is the cot function. This is how the cot function looks like. So
Okay.
you can draw the other function like sec also. So this is how sec look like. Again, what is sec? Sec is the reciprocal of cos. So this means that wherever cos is 0, at those points sec would not be defined. So sec function, sec x, would not be defined at pi by 2, 3 pi by 2, again at all the odd multiples of pi by 2. You can go in the negative also. So this is how the functions, how these 6 important trigonometric functions look like.
Okay.
So this is, since we are running out of time, this is an example you can work out. So in this example, if cos x is minus 3 over 5,
Okay.
3 over 5, and it is also given that x lies in the third quadrant. So children,
Okay.
in the third quadrant, if you ask the third quadrant what all trigonometric ratios are negative, so cos is negative there, only tan is positive, all the other trigonometric, so it is in the third quadrant. So what
Okay.
do you want to find? You want to find the other trigonometric function. So cos is given, so one trigonometric is given. It is being asked that find what is sine x, what is cos x, cos x is given, what is tan x, what is cot x, what is sec x. So you can find this. I'm just giving a hint to find all the other trigonometric ratio. So how you are going to find? You're going to find by using this sine square x plus cos square x, this identity which we have already done. So you know from here what you can calculate? You can calculate sine x. So once you calculate sine x, cosec x is known. But while you finding sine x, just make a consideration that it is in the third quadrant. So in the third quadrant, sine is negative. So you have to take, you will get 2 values. Out of those 2 values, you have to take the negative because sine is negative in the third quadrant. So sine would be found from this identity. So once sine is found, cosec could be found, which is reciprocal of cosine. That once sine is found, sine and cos is found, tan is found. Because what is tan? Tan is sine over cos. So cos is already known, sine would be known to you. So tan would be sine over cos. And
Right.
what is cot now? And cot is reciprocal of tan. So whatever tan you will get, the reciprocal would be cot. So this is all about trigonometric. It is a very important, trigonometric functions are very important functions, and a very basic understanding of these functions should be known to the student.
Right, Dr. Ajit Thomas has explained very well sine, cos, cosec, tan, sec and cot. all these, you know, related to each other. You just need to understand the difference, and you know the equations as sine square theta plus cos square theta is equal to 1, right, Dr. Ajay Thomas?
Yes.
Okay,
Yes,
thank
sir.
you very much. This is my understanding, a little understanding, but you will make it big. ये हमारा सेशन YouTube पर रहने वाला है, so you can watch it later on once you need it. So you have to revise all the 4 sessions now. So now we are concluding part 4. Thank you, Dr. Raju Thomas. You have joined us for this session. Thank you very much.
Thank you very much. Thank you very much.
So ये सेशन हम यहीं समाप्त करते हैं. We will be right back with the next session of Home Economics and Family Science, class 11th, and the topic is community and society. So don't go away. Stay tuned. Kishore Manch. Namaskar.